if I go to this search facility and put in domain, the earliest paper that seems to mention it seems to be 1981 D.L. Mills.
We deceive you.
There's David Mills, and RFC 799 has 7 sections. First, a quick introduction, then section 2 is called General Topology. The third section gets into it, and it's called Naming Conventions. Section 4 is about principles, it's called Mail Transport Principles. Section 5 is called Forwarder Operations. What can we expect the forwarder to do? And section 6 is about source and return routing. And then finally, in section 7, David Mills talks about the RFC 733 header. 2 key characters. We've got the mail relayer.
Letter for you.
Now the relayer, which is represented by this Muppet, is equipped to store an MTP message, a mail transport protocol message, or transfer protocol message. If you think about what relaying is, you take some sort of message, you hold on to it, then you pass it on. But it's not competent in all domains.
I'm fixed like no other company in this field, and that's...
Here's our mail forwarder. He can do everything our mail relayer can do, and more. He's connected.
I have business connections, so I can get the lumber for the derrick. Such things go by friendship in a rush like this.
In fact, relayers are this broader category, and a specific type of mail relayer is our mail forwarder. So something might be a mail forwarder and a mail relayer. You might have something that's just a mail relayer, it's merely a relayer. We also have these things called mail recipient commands, or MRCP for short, MRCP commands. And these have 2 fields. This is all you need to know. They have a recipient route field. I think it means that the recipient fills out the field, and then the sender route field. And so 2 different fields. So there are entries within each of those fields, and we're going to talk about those. Fourth thing, just to quickly let you know about, is RFC 780. David Mills is going to be referring to this RFC 780, which came earlier, in fact only a few months, May of that year, and it was called Mail Transfer Protocol by these 2 authors, John and Suzanne. And throughout this paper, it's basically about mail. There's this distinction, of course, between the sender host and the recipient host. Sometimes instead of using the word sender, we use the word source, which is basically what the sender is. A sender is a source in the context of mail, but sometimes we even use the word originator. There's also this threefold action. You've got the user. This is obviously I think this is a human that uses a host. You've got a host, which is some machine that accesses the network, and of course our domains. The sender, the recipient, even the forwarder, and I think the relayer, they basically are hosts. I mean, the forwarder is a process. It's described as a process, but it's a process on a host, so these are hosts. Internet name domains. Introduction. In the long run, it will not be practicable for every internet host to include all internet hosts in its name address tables. So those hosts, which we saw earlier, which users use, they have name address tables which map names to 32-bit IP addresses. But this is getting troublesome. Even now, with over 400 names and nicknames in the combined ARPANET DCNet tables, because presumably they mashed their tables together, this has become awkward. some sort of hierarchical name to space partitioning, or namespace partitioning can easily be devised to deal with this problem. However, it's been weirdly difficult to find one compatible with the known mail systems throughout the community. Now, the one proposed here in RFC 799 is a product of several discussions and meetings, and is believed both compatible with existing systems and extensible for future systems involving thousands of hosts. David L. Mills works for ComSat Laboratories. So ComSat was originally created in 1962, the Communications Satellite Act of 1962. It was a federally funded corporation to develop a commercial and international satellite communication system press. And President John F. Kennedy appointed a 6-person board of directors to begin with. And then ComSat set up, still in the 60s, in 69, ComSat Labs, which was the research and development arm based in Maryland, and the founding director was called Bill Pritchard. Section 2, General Topology. So he's going to set out this new system. We first observe that every internet host is uniquely identified by one or more 32-bit internet addresses, and that the entire system is fully connected. For the moment, the issue of protocol compatibility will be ignored, so that all hosts can be assumed to be competent regarding the mail transfer protocol, which was set out in RFC 780. We next impose a topological covering on the space of all internet addresses, with a set of so-called name domains. In the natural model, name domains would correspond to institutions, such as the Advanced Research Projects Agency, UCL, University College London, and ComSat, and would not be necessarily disjoint, separate, or complete. While in principle name domains could be hierarchically structured, we will assume in the following only a single level structure. So they could themselves, these name domains, they could themselves be with structure, but let's just assume now that it's only the namespace that has structure because we've brought in these. Let's keep it simple for now. Every name domain is associated with one or more internet processes called mail forwarders.
I have business connections.
And that's every name domain. So what is a mail forwarder? We're told it's just a process, and the idea is that every domain has its own forwarder, might even have multiple forwarders, and the name of that domain is also the name for any of these processes. So presumably, if there's a domain that has 3 forwarders, all those 3 forwarders would have the name of the domain? Maybe. Each forwarder process for a particular domain is expected to maintain duplicate name address tables containing the names of all hosts in its domain, and in addition, the name of at least one forwarder process, one forwarder, for every other domain, so each forwarder knows about the other domains. They are connected, as we said. Forwarder processes may be replicated in the interests of robustness. However, the complexities about that won't be discussed here. A particular internet host may support a number of forwarder processes, and their collective names, they represent nicknames for that host. So the names of the forwarders are just the name of the host, in addition to any other names that host may have. In the following, an internet host supporting one or more forwarder processes will be called simply a forwarder. So even if it does support, say, 3 forwarders, we're just going to call it a forwarder. Even though technically the host supports the forwarders, we're just going to say it's a forwarder. So we're not going to say host that supports forwarder, we're just going to call it a forwarder. Every host is expected to maintain name address tables, which include the names of at least one forwarder for every domain, together with additional hosts as convenient. A host may belong to several domains, but it is not necessary that all hosts in any domain be included in its tables. Following current practice, several nicknames may be associated with the principal name of a host in any domain, and these names need not be unique relative to any other domain. Okay, so the principal name, the main name, that presumably does have to be completely unique, even across all domains, but nicknames don't have that requirement. They might be conflicting with names in other domains. Furthermore, hosts can be multi-homed In other words, respond to more than one address. For the purpose of mail forwarding and delivery, we will assume that any of these addresses can be used without prejudice. The use of multi-homing to facilitate source routing is a topic for future study. Section 3. Naming conventions. In its most general form, a standard internet mailbox name has the syntax user, then a full stop, then the host, then the @ sign, and then we want that domain. So user, host, where user is the name of a user known at the host in the domain. This syntax is intended to suggest a three-level hierarchically structured name, reading from the right, which is unique throughout the internet system. However, hosts within a single domain may agree to adopt another structure, as long as it doesn't conflict with the above syntax, and as long as the forwarders for that domain are prepared to make the requisite transformations. And of course, forwarders are themselves hosts. Now, he's now going to give an example, and he's going to use these examples. So the user is going to be Mills, the domain is going to be Comsat, and the host is going to be Comsat DLM. You can imagine that stands for David's Little Machine or something. So for instance, let the name of a domain including DCNet be Comsat, and the name of one of its hosts be Comsat David's Little Machine, with Mills as the user known to the host. From within the Comsat domain, the name Mills at, and then look, he's put the name of the host after the @ sign, Mills at Comsat DLM, that will uniquely identify that mailbox, but only from within the Comsat domain, note. As could, for example, the name mills.comsat DLM, so dot and then the name of the host, Comsat DLM, at Comsat, from anywhere in the internet system. So if you had that, where you have the domain name after the @ sign, that's unique anywhere in the whole internet system. However, Mills at Comsat DLM is not necessarily meaningful anywhere outside the Comsat domain, but it could be, but not necessarily. DCA, Defense Communications Agency. A typical set of name domains covering the current internet system might include ARPA, Comsat, DCA, UCL, MIT, and Intel Post, and the various public data networks. So these are institutions, some of which are still around. So you've got UCL, that's University College London, MIT. Notice that Comsat, that seems to have DCNet. So when they talk about DCNet, that is the system run by Comsat, and ARPANET is run by ARPA. DCA is the Defense Communications Agency, now known as DISA. The ARPA forwarder would use a name to address table constructed from the latest version of the hosts.txt table in the NIC database. It's the Network Information Center in Stanford. The other forwarders would construct their own, but be expected to deposit a copy in the NIC database. Internet Post, or Intel Post, stood for International Electronic Post. The United States Postal Service wanted to create an electronic version of Post. Section 4, Principles. So remember this distinction between sender and sender host and recipient host. We might call the sender the source or the originator. In the interests of economy and simplicity, it's expected that the bulk of all mail transport will take place directly from originator to recipient host. There won't be any relay. A technique of caching will probably be necessary for many hosts in order to reduce the traffic, and forwarders will then merely learn the internet address associated with a particular correspondent host. And that naturally encourages naming strategies designed to minimize duplicate names in the various domains. However, such duplicates are not forbidden. Okay, But there are several reasons why some messages will have to be staged at an intermediate relay, so it won't be direct. So why might that need to happen? Well, it may not be possible or convenient for the originator and recipient hosts to be up on the internet system at the same time for the duration of the transfer. The originator host may not have the resources to perform the translation from name to address, which needs to happen. A direct connection path might not be feasible due to regulatory constraints or economic constraints or security constraints. The originator and recipient hosts may not recognize the same lower level transport protocol, e.g. TCP and NCP. A mail relay is an internet process equipped to store an MTP message for subsequent transmission. Okay, so this is another process. We've already seen the forwarder, but a relay is a process that holds on to things. So we've got two examples of internet processes now, mail forwarder and mail relay. A forwarder is a mail relay, but not all relays are forwarders, since they might not include the full name-to-address capability required of forwarders. In addition, relays may not be competent in all domains. For instance, an MTP TCP relay may not understand NCP. In other words, the forwarders must be fully connected, but the relays may not. We're now going to start talking in this section, section 4, on principles about the mail recipient command, which is defined in this 1980 RFC, a year earlier. So this is a command used to identify the recipients of the mail, if there are multiple users at one host. Okay, so MRCP. The particular sequence of relays traversed by a message is determined actually by the sender by means of the source route specification in the command, in that MRCP command. So the sender determines which relays are going to be passed through by the message. Okay, so we have something called the source route specification. And this has a few implications or consequences. I mean, this means that advisory messages returned to the originator by a relay, or even by the recipient host, are expected to traverse the route in reverse order, because they have to go by what's in the source route specification. Relay host names follow the same naming convention as all host names relative to their domain. Since it may not be possible to use internet addresses to disambiguate the domain, to tell apart the domain, work out which domain a particular host is a part of, the complete standard internet name, so .host at domain, that is required everywhere. There is no current provision for strict or loose route specifications, so sometimes it looks like there's this thing that they're familiar with where you could either have a strict or a loose route. If in fact the ordinary host specification, which is where you, instead of having at domain, you'd have at host, if that were used, each relay or forwarder would use the rules outlined in the next section for routing. This may result in additional relay hops. Relay, so you'd have to go through more of those relays in the middle there. To be honest, it's hard to see how those are implications of the sequence of relays traversed by the message being determined by the sender, but there we go. Section 5, forwarder operations. We're focusing on the forwarder now. which fields does the forwarder have to look at in that command. This section describes a likely scenario involving hosts, relays and forwarders, and typical internet routes. When a forwarder receives a message for user.host at domain, which is the correct syntax, it transforms host if necessary and forwards the message to its address, found in its name to address table for that particular domain. Because remember, it has a table for each domain, it's been given a name, so it now needs to find the address for that. Note that a single host can be a forwarder for several independent domains in this model, and that these domains can intersect, and that's very important. So this particular forwarder, he passes on messages, he uses his table to put names to addresses. He actually supports many domains. And this means that the names, let's look at these three names, mills at USC ISIE. Okay, so USC was just University of Southern California. ISIE, this ISI is the Information Sciences Institute, so you could imagine that ISIE is a particular computer they have in the Information Sciences Institute. Maybe they call it the ISI emailer, and so it got called the ISIE. So you've got mills at USC -ISIE, mills dot, and then that host name at ARPA, and mills dot the host name at ComSat. So at ARPA at ComSat, and as we know, those are domain names which were suggested by Mills. So those three names can all refer to the same mailbox. And that follows from the fact that a single host can be a forwarder for several independent domains, or rather, the domains can intersect, because maybe that mailbox is in the ARPA domain and the ComSat domain. So that follows. So the fact that those three names refer to one mailbox follows from the fact that domains can intersect. And the names USC, ISIE, ARPA, and ComSat can conceivably all be known in the same domain. Such use would be permissible only in case the name USC ISIE did not conflict with other names in this domain. Which domain? The ARPA domain. But that's the point he's making. That name USC ISIE has to not conflict. In order for this scheme to work efficiently, it is desirable that messages which are going across forwarders or transiting those forwarders always contain standard internet mailbox names. Okay, so we've got a message that goes across forwarders, and when this is not feasible, like in the current ARPANET mail system, the forwarder must be able to determine which domain the message came from and edit the names accordingly. This would be necessary in order to compose a reply to the message in any case. Now in the RFC 780 model, a message arriving at a forwarder is processed by the MTP server there. I just need to get rid of those relayers, we're talking about forwarders here. And we're also going to introduce this character, the MTP server. So in that model, a message arrives at a forwarder, and it's really the MTP server that does things. So what does the MTP server do, the Mail Transfer Protocol server? Well, it extracts the first entry in something called the recipient route field. Okay, we've already talked about the source route specification, and we said that there are those four implications of the fact that we use the source route specifications, like the fact that if you had an advisory message, it would have to do the reverse route. But now we're talking about the recipient route specification. So the MTP server extracts the first entry, and in a minute it's going to look at the second entry. So it extracts the first entry, and there are two possibilities, right? Depending on whether this entry specifies a domain name or a host name. So if it specifies a domain name, then the MTP server will know that it's a domain name because it's checked its table, and yeah, I think it just passes it on to the relevant domain if the forwarder works for that domain, because remember that point that forwarders can sort of cover several domains. But it might not. The first entry of that field might actually specify a host name. All right, so if it specifies a host name, then that MTP server has got to find a name or a nickname of that server's host kind of related to a particular domain, because remember, hosts sit in domains, so it's got to do a little bit more work if it's a host name that's given in that entry. So remember, that sender will belong to some domain. This allows a distinction to be made between the domains ComSat and Intel Post on the one hand, and also the ComSat host, ComSat PLA, on the other, all of which might be represented by the same internet address. Okay, so are we saying that you'd have one internet address for the two domains ComSat and Intel Post and a host, okay, and implies that domain names must be unique in all domains. So what does this guy do next? So he's extracted the first field of the recipient root, the first entry in the recipient root field, but then he looks at the second entry in the recipient root field and he resolves its address relative to the domain which was established by the first entry. If the second entry specifies an explicit domain, then that overrides the first entry, but if not, and the first entry did specify a domain, then that domain is effective. Okay, that's the kind of detail. However, if the first entry specifies the server's host, the name of a host, it might not be apparent which domain is intended. Okay, we might have a problem here. Okay, if the first entry doesn't give a domain, it gives a host, we need to know, well, what domain is that host in? So for instance, consider the following two mail recipient commands. So you might have mrcp to there's the two commands. That's not them entirely yet, but notice how they're both going to have mils at host. Now the first command is comsat, and the second command is at Intel Post. And mils.host at comsat and mils.host at Intel Post are distinct mailboxes, and they're on different hosts. So this example is supposed to demonstrate that it may not be apparent which domain is intended. Okay. Now a receiving host or a recipient supporting forwarders for both ComSat and Intel Post can then preserve this distinction and forward correctly using the above rules. Okay. So yeah, summarizing, there's this forwarder. He has to process message, or the MTP server processes messages which arrive at the forwarder. He looks at mail recipient commands, and we're focusing on the recipient root field. In that first entry, he either finds a domain name or a host name. It's good when he finds a domain name there because he has a universal table for that. He knows where to send the message. We then go to the second entry. Sometimes that has a domain name. If it does, it overrides the first name. Okay. Now let the forwarder have the name forwarder in both the ComSat and Intel Post domains, and consider its options when receiving the command. So we're talking about the forwarder here. Forwarder mils host. So this is a bit like before, but instead of ComSat and Intel Post, we've got forwarder. The forwarder is being asked simply to relay within the domain of the sender, so the sender's domain. However, the forwarder belongs to more than one domain. He's part of both domains, and that's a problem, hence the exclamation mark. The obvious way to resolve this issue would be to forbid the use of implicit domains, as represented by mils at host, and require the full internet mailbox names mils.host at comsat or mils.host at Intel Post. It is also possible to disambiguate the domain by inspecting the first entry of the sender root field. We haven't talked about that, we've been focusing on the recipient root field. Quite a confusing section, that, section 5, but we're now on to section 6, routing. So there are two commands, the mail recipient command and the mail command. And these commands have fields in them. That's the idea. In the RFC 780 model, routes can be specified in the recipient root field of the mrcp command. We've been talking about that. Okay, so in that command, the mail recipient command, we use the recipient root field. And if we're talking about the mail command, we tend to use the sender root field. Okay. In point of fact, neither the recipient root or sender root is necessary if the originator specifies standard internet mailbox names. So this whole paper really is just a big argument for these standard internet mailbox names. So long as the roots, when used, consist only of domain names, there is no conflict with the current RFC 780 specification. If for some reason forwarding must be done via other hosts, then the use of a complete and unambiguous syntax like user.host@domain is required in order to avoid problems like that described above. The present RFC 780 specification requires the receiver to construct a name for the sender and insert this at the beginning of the sender root. Okay, so the burden is on you, Harry, the receiver. Presumably, the only information it has to construct this name is the internet address of the sender. Consider the case as in the example above, where multiple domains are supported by a single server on a particular host. Okay, multiple domains supported by a single server on a particular host. If hosts receiving a message relayed via that server that we mentioned, the one that supports many domains. So if messages were relayed via that server, well, if hosts receiving a message relayed via that server were to map that server's address into a name, there would be no way to determine which domain was intended. We conclude that the sending host must update the sender root as well as the recipient root. So you have got to do things, the sender. And it does this simply by copying the first entry in the recipient root as received as the new first entry in the sender root. Section 7. Editing the RFC 733 header. Every effort should be made to avoid editing the RFC 733 header, since this is an invasive procedure requiring extensive analysis. It's expected that newly developed mail systems will be aware of the standard internet mailbox syntax and ensure its use everywhere in the RFC 733 and RFC 780 fields. On the occasions where this is not possible, in other words, the newly developed mail systems are not aware of the syntax, well, on occasions where this is not possible, such as in many current ARPANET hosts, the necessary editing should be performed upon first entry to the internet mail system from that local mail system, which is old and decrepit. This avoids the problems mentioned above and simplifies reply functions. Now, in the case of these old and defunct ARPANET hosts, the editing operations assume that all names in the form anything at domain, where domain is the name of a domain, are unchanged. Names in the form anything at host, which are of course problematic, where host is the name of a host in the ARPA domain, are transformed to the form anything.host at ARPA. Anything else is an error. Before handing off to an ARPANET NCP mailer, an ARPA MTP forwarder might optionally transform anything.host at ARPA to anything at host in order to reduce the forwarder traffic when local mail systems are available. Similar situations might exist elsewhere. So there are situations where we might want to have at host rather than at main because it reduces traffic, but we have to make sure it's not going to cause confusion. 8. Concluding remarks. This memorandum is intended to stimulate discussion, not simulate it.
Hey, we got culture.
Yeah, we got culture coming out our ass.
All right.